Here we are, 3.2. So after having to have proven that those triangles are similar, right, we can easily write out stuff like GG over GE. Yo, bro, GE, man, come on, GE. GE is equal to DE over EF, which is equal to DE over DF. It's quite interesting, quite interesting, quite interesting. The fortunate thing is what we need to prove there looks quite simple because there's DE squared, right? So we may have to consider this here. Okay, this is how you're gonna do it. You see, there's a DE here. So you wanna tick a DE there and a DE there. There's DF, so you wanna check off this DF. And then there's DG. So this DG is obviously going to cause problems for us. So you want to give it like a, you know, a question mark there. But then the other thing is, I'm like, DE is equal to all these other lines here. This is one thing you have to be careful of. DE, let's make it pop. DE is equal to, yeah, let's make it stand out. DE is equal to FE, and it is equal to FG. So the idea is, you see, even though we've marked off all these, it doesn't look like this is helping us much. And the other sad thing is, I mean, yeah, let's see here, DG over GE is equal to DE over EF, and then DE over DF. Oh, this is quite interesting. This is quite interesting. So the ones we've checked off, right, are these here. We've checked off DG there, we've checked off DF there, we've checked off DE there. So we've checked off something from somewhere. So it looks like this one definitely qualifies for something that we need to carry over to our next step. So this one, DE over DF, we just have to be careful now of what we're going to make it equal to. Well, there's a D G here, right? There's a DG over there. So in terms of DG, I mean, this one is going to be a bit tricky because I'm like, it looks like we definitely have to have the DG some way, somehow. The GE, yeah, I think that one is going to be a problem, to be honest, because I'm like, you know, it's just a random GE. But I think, you know what, name? Let's actually, this one may actually be the one that is going to give us problems. Because the thing is, I think here we have to think creatively. Because with this specific question, right, even though all these are in our expression, the thing is, DG ne, can be written as DF and FG. Yeah, of which the FG, we can always write it as DE if we need to. So this one, let's just disregard it because the DF here and the DE, I mean, these, we can write them in terms of the DG over there. And then, or rather the GE here. No, bro, what are you saying? What are you saying? Ah, crap. You know what, ne? Let me just, hey, what am I doing now? Hey, it's difficult, ne? It's difficult. Okay, what I'm trying to say ne, is the DG here. There's a DG somewhere. Fine. But then the GE, it looks like the GE is going to cause us problems because, I mean, like, you know, it's just a random line. There's a GE here, but there's no GE anyway here. And it's going to be difficult for us to write any of these in terms of like a GE. So let's go for these two and see what happens. Let's go for these two and see what happens. Let me just rewrite them nicely. So let's put here DE over EF. You'll see the method to the methods just now. This is equal to like DE over DF. Now the reason for writing this is just proportionality theorem. Okay, fine. Now let's do what we can. So if you cross multiply here, ne, you're gonna have DE dot DF ne, equal to EF dot DE. Now the problem, so looking at what we have ne, here, we need a DE. So fine, there's a DE there, there's a DE there. So I mean, like, we'll see. There's a DF, fine. But then there's a DG here, whereas we have EF. So EF, I mean, the one thing is EF can be written as DE. So we'll have our DE squared. So yeah, this one is kinda Hey, yeah, ne? Wait, let's just carry on with here with this and see what happens. Let's just carry on and see what happens here. Because here we're gonna have DE, right? Dot DF. But then what we know is that EF is equal to DE, you know? So, okay, wait, let me just do this. Let's firstly write here EF is equal to DE. This is something that's given, you see. EF is equal to DE. This is given. So if that is given, it means that the next step, we can write DE times DF is equal to DE squared. Fine. So we have our DE squared somewhere, somehow. We have our DF here. Now the problem is the DG. We have our DF here, like the DG, like yeah. I feel like this one I probably may have made a mistake somewhere. I hope I didn't, because it is definitely a bit annoying as a question. Like just looking at it, it is a bit annoying. But so far we have the DE squared, we have the DF, but then here where there's a DE, we practically have a DG on the other side. There's something wrong here. I feel like I should just stop this one, check it out, and then look at it nicely. But let's see, DG over GE is equal to DE over EF, which is equal to DE. No. I wrote down the wrong ratios here, Paga.